Hi everybody. Just wanted to go over the test with you since we don't really have a classroom to do that in, so that you can look at the test you submitted to me and see why you lost some points. All right, so the first one we have to do is find the solution to the system by graphing. So we're going to graph. So we need y equals mx plus b. So if we have x plus y equals 0. And we solve for y. We subtract x from both sides. When we subtract x from both sides, we get y equals negative x. So we know our slope is negative 1, and we know our y-intercept is 0. Now we have to do that for the second one. So we have 2x minus y equals negative 3. And we have to solve this equation for y. So subtract 2x from both sides. And we get negative y equals negative 2x minus 3. Careless mistake here is to forget to divide through by negative 1, because remember, you want to solve for y. So y equals positive 2x plus 3. So your slope is 2 and your y-intercept is 3. So now we're going to graph. Come over. For some reason, when I download this, it took away all the graphs that were here. There we go. So let me change my color here. So the first one is a y-intercept of 0. So we put a point on our origin. And then our slope is negative 1. So remember, you go down 1 and right 1, or you can go up 1 and left 1. Some of you didn't put points. You just sketched in a line. For solving by graphing, you have to be very exact. So I wanted to see some points being plotted to show me that you knew what the slope was. Okay? And it appeared on some that you really weren't sure, some of you, because it wasn't in alignment with what the slope really was. The second line is y equals 2x plus 3. So the y-intercept is at 2. So put a point at 2. And then, at 3, I'm sorry, the y-intercept is 3. The slope is 2. And then go down up to over 2, which you could do up to over 1. I just said up to over 2, which I'm really losing my mind now. I just had to do this video 5 times because it wouldn't let me continue. So anyway, sorry about that. Or because we want to see where it intersects the other red line, we should go probably down 2 and left 1. And when we do that, we get an exact point of intersection. So we can see that these two lines intersect at the point negative 1, 1. Remember, you can do a quick check by substituting the negative 1, 1 into the two original equations right up here. So if you put negative 1 plus 1, you would get 0, yes. If you put in negative 1 in the second equation, you'd get negative 2 minus 1. Negative 2 minus 1 is negative 3. So both of those work. So a quick check that you can do in your head tells you if you got the right answer or not. I suggest you do it because there's no reason for you to get a wrong answer if you do a quick check. Second equation, x plus y equals 8. X plus y equals 8. Again, we have to solve for y, so we're going to subtract x from both sides. So when we subtract x from both sides, we get y equals negative x plus 8. So our slope, we just go up a little bit here. So our slope is negative 1, and our y-intercept is 8. Now we have to take that second equation, which is 3x minus y equals 4. So if we solve for y, again, we have to subtract the 3x. And we get negative y equals negative 3x minus 4. Careless mistake here is not to divide by the negative 1. So again, divide by negative 1, and y equals 3x plus 4. Okay, and this is a plus 4, and I wrote minus 4, so this would be actually negative 4 right here. So 3x minus 4. So m is 3, and b is negative 4. Plot. And we have an 8 and a negative 4, so we're going to go like this. And go 1, 2, 3, 4, 5, 6, 7, 8. And down 1, 2, 3, 4. And we can go over a couple here. There we go. So I change my colors here. So the first one, b equals 8. So we go up to 8 and we put a point on our y-intercept. And our slope is negative 1. So down 1, right 1. And we could do that a couple of times. Okay. And then our line, nice and straight. Second one. Second line we have, let's do blue. We have b is negative 4, so let's put our point here. And then slope is 3. So up 1, 2, 3 over 1. And again, you would go up 1, 2, 3 over 1. And again, you would go up 1, 2, 1, 2, 3 over 1. And draw your line. And it looks like we're at 1, 2, 3. X is 3. And y is 1, 2, 3, 4, 5. So 3, 5. Again, I'm going to quickly check. I'm going to go to my original equations. X plus y equals 8. So 3 plus 5 equals 8. Yes, it does. And substituting the 3 and the 5 into the second equation, I would get 9 minus 5 equals 4, which is true. So again, a quick check that you can do in your head to make sure that you have the right ordered pair for your solution. I don't know what happened here when this changed from a PDF to a Google Doc, but whatever. All right, number 3. Now, what's the difference? Now you have an inequality. So as soon as you see that word inequality, you're thinking shade. All right, we're going to have to shade. So that first equation, y is greater than or equal to x minus 4. Already solved for y, so our slope is 1 and our b is negative 4. And then we have to decide it's greater than or equal to, so we have a solid line. And it's greater than or equal to, so we're going to shade above the line because y is getting bigger. Where does y get bigger? As it goes up the axis. Okay. The second one is y is less than or equal to negative 2x minus 8. So already again solve for y. So our slope is negative 2 and our y-intercept is negative 8. It's less than or equal to, so now again we have a solid line because it's equal. And it's less than or equal to, so we're going to be shading below this time. Because where does y get smaller? As it goes down the axis. So now we're going to graph our line. So let's do this. I'm going to make this a little lighter so it's easier. And we have a y-intercept of 4, and then 5, 6, 7, 8. Okay. So our first one, we have a y-intercept of -4. So we go to -4 and we put a point. Our slope is 1. So we're going to go up 1 and right 1, up 1 and right 1 again, or down 1 and left 1. And then that gives us a very good idea of what our graph looks like. I drew a solid line because I remembered that my line was going to be solid. Okay, so I did draw the solid line. And then it says to shade above. So where does y get bigger? As it goes up the axis. So you're going to shade above the axis. Now you're going to plot that second line. That second line has a y-intercept of -8. So I go down to -8, plot my point. The slope of that line is -2. So go up 2 and left 1. 1, 2, left 1. Now if I draw that line, which is also solid, looks like that, and then it says to shade below. Well, you can see where the purple and the red lines overlap. The purple and the red lines overlap right in here. So you're going to shade that area in so that you know those are the points that are the solution to the problem, the inequality. If you don't darken it in, then you're not telling me that you understand the material and that you don't know where the set of solutions are. But every single one of these points in this area, which would of course continue because this line continues and this line continues. So really, like, all of this is the solution, infinitely many, but only those in that section that keep continuing. Next one. Same situation, you have inequalities. So y is less than or equal to, I think that's supposed to be, let me just make sure. Yes, I don't know why these numbers are getting all goofed up. So y is less than or equal to -3x minus 1. So the slope is -3 and your y-intercept is -1. Again, we look to see it's less than or equal to, so solid line. It's less than or equal to, so you're going to shade below. Second equation is y is less than or equal to 2. You have to recognize that this is a horizontal line. So it's a horizontal line, and it's less than or equal to, so it is a solid line. And it's less than or equal to, so you're going to shade below or under, since it's horizontal. Okay, so now we're going to draw our graph. All right, so the first graph is b equals -1, so go down to -1, draw your line. The slope is -3, so you're going to go down 1, 2, 3, and right 1. Or we know we can go up 1, 2, 3, left 1. So that, again, that's what I want to see, at least 2 points on the graph and you drawing a line through it. The second line is a horizontal line, remember? So the horizontal line is at y equals 2. So go up to 2, put your point, and now it's horizontal. Before I draw my line, I decide if it's solid or dashed. It's solid, so I'm going to go straight across. And I didn't shade that first one, so I should go back and shade that. But I'm first going to, since I'm here, I'm going to finish shading this. So it says less than or equal to y. Y is less than or equal to 2, so shade below that line. So we're going to shade below. So I just make some lines showing me where I would shade. If I was shading that first one, okay, it was also below. So that means I'm going to take and I'm going to shade below here. Okay, so where did it intersect? It intersected over in here. Don't go above that purple line because it's just all in here. Below the purple line and to the left of the orange line. All right, hope this is helping. Now the next set of problems are solved by elimination. That's when you're going to add the two equations to eliminate one of the variables. And if you can't add the two equations and eliminate one of the variables, that means you have to multiply one or both of the equations in order to make those coefficients of one of those variables opposite numbers, so that when you add them, they are eliminated. If we look at number 5, we notice right away that the y has a -3 and a +3. So when we add those two equations, the y's are going to be eliminated. So 5 and 3 is 8x, 3y minus 3y is 0, and -16 and -24 is -40. Divide both sides by 8, and x equals -5. You have to remember here, solve by elimination. Well, what am I trying to do? What's the purpose of solving this equation? The purpose of solving this equation is to find out where do these two lines intersect. Okay? Where do these lines intersect? That's what you're finding out. Well, where do they intersect? They intersect at an ordered pair. Well, you found x. Therefore, we need to find y. So we take on what we know, and we know x is -5, and we go back to the original equations, and we choose one of them. It doesn't matter which one. I'm going to choose the second one because they're both positive, less apt to make careless mistakes, and we're going to substitute now. So 3 times x, which is -5, plus 3y equals -24. That's -15 plus 3y equals -24. Now we have to solve for y, so we're going to add 15 to both sides of the equation. 3y equals -9. Divide by 3, and y equals -3. Remember, your answer is an ordered pair, so don't stop here. You need to show me that the ordered pair, the point where these two lines intersect, is -5, -3. That's your solution, the point of intersection. If you graphed both of these lines, that's what you would get. Okay? Going just to erase some of this now because I need some room to do this. Next one. Same thing. You're going to follow the same rule on this one. Okay? So what do we have? We have 2x plus 4y equals -3, 4x minus 4y equals 6. So again, look right at those variables and look at their coefficients. The x has a 2 and a 4. The y has a 4 and a -4. Ding, ding, ding. 4 and -4 are going to go 0. So we can just add. We don't have to worry about anything. Those are going to cancel out. So 2x and 4x is 6x. And -3 and 6 is 3. Divide both sides by 6, and x equals 1/2. Now we know what x is. We have to find what y is. I would choose that first equation. Again, you can choose the second one. It's the same point of intersection is on both lines, so it doesn't matter. And now we're going to substitute. So 2 times x, which is 1/2, plus 4y equals -3. That's 1 plus 4y equals -3. Subtract 1 from both sides, and 4y equals -4. Divide both sides by 4, and y equals -1. So now I have a value for x, which is 1/2, and I have a value for y, which is -1. So those two lines, if you were to graph them, would intersect at the point 1/2, -1. And again, you can plug them into the original equations to make sure you get the right answer. All right, let's do the next one. Just going to erase some of this so I have some room. All right, so the next one we have 4x minus 3y equals -6, and 8x minus 6y equals -12. Well, now when we look at those, they don't have neither coefficient, neither x nor y has opposite coefficients. Okay, so we have to make them opposite. So if I choose to get rid of my x's, one is 4 and the other coefficient is 8. So if I multiply that 4 by -2, I'm going to get -8. And when I add -8 to 8, it's going to be eliminated, hence the name of the process. So it doesn't matter whether you choose x or y to get rid of. I just see that the x's are going to eliminate quickly if I multiply through by -2. So when I multiply through by -2, I get -8x plus 6y now, because it's a negative times a negative, equals a -2 times -6, positive 12. Be very careful with your negatives. 8x minus 6y, just copy the second one down because we don't need to do anything to it. And now most of you, if not all of you, are going to see that this is all going to cancel out. So we're going to have 0 plus 0 equals 0. Well, when does 0 equal 0? Always. It always equals 0. So the answer is all real numbers. Well, you know the symbol for all real numbers is the funny looking R. I hope everyone is seeing this now and it's becoming clearer for those of you who had some trouble with it. Number 8. Oh, so now number 8, the first thing I look at and see is that 3x equals 9 minus y isn't in standard form. I want my variables to line up underneath each other. So I'm going to first have to take this 3x equals 9 minus y, and put it in standard form. So I'm going to add the y to both sides. That's going to give me 3x plus y equals 9. Remember standard form, ax plus by equals c. So now I'm just going to write that down. I'm going to go up here actually so I have lots of room. 3x plus y equals 9. And we have negative 2x plus y equals negative 1. All right, so I look at my x's. They are not the same and they're not opposites. I look at my y's. They are the same. They have the same coefficient. The coefficient is 1. We want them to be opposites. So that means we have to multiply one of those equations by negative 1. Because there are a lot of negatives in the second equation, I'm going to multiply that second equation by negative 1. And when I do, I get a positive 2x, a negative y, and a positive 1. I now copy down the other equation. I don't have to do anything to it. And now I see that my y's are going to be eliminated when I add. So I have 5x equals 10 and x equals 2. If I have x equals 2 and I choose an equation, okay, I'm just going to choose 3x plus y equals 9, and I'm going to substitute in 3 times 2 plus y equals 9. That's 6 plus y equals 9, minus 6, and y equals 3. So what is my ordered pair? 2, 3. I'm going to quickly check it, so I'm going to go up to my original problem. If I put 2 in for x and 3 in for y, I'm going to get negative 4 plus 3 is negative 1. That's true. If I put 2 in for x, I get 6 equals 9 minus 3. 6 equals 6. Also true. So I know 2, 3 is the right answer. Number 9. Number 9, solve. Again, we're just using elimination. Okay, I don't know why, again, this didn't copy right. But anyways, this would be 3x minus 4y equals 21, and 4x plus 2y equals 6. Okay, so if I see here, my x's are 3 and 4, the coefficients, and I look at my y's, and my coefficients are negative 4 and 2. So I know that if I take and I multiply this second equation by 2, my y is going to have the coefficient of 4. And when added to negative 4 is going to cancel out. So I'm going to copy down my first equation, 3x minus 4y equals 21. And I'm going to distribute the 2 on my second equation. 8x plus 4y equals 2 times 6 is 12. That's 11x. The 4y's cancel out, equals 33. Divide by 11 and x is 3. Now I have to find y. So I'm going to take 3x minus 4y equals 21 and substitute. So 3 times 3 minus 4y equals 21. Just make this go up a little bit here. Okay. And when I do that, I get 9 minus 4y equals 21. Subtract the 9, and negative 4y equals 12. Divide by negative 4, and y equals negative 3. So where do they intersect? They intersect at 3, negative 3. And again, quickly, if I go up and I check my answers, 4 times 3 is 12, plus 2 times negative 3 is negative 6. 12 and negative 6 is 6. If I check my first one, 3 times 3 is 9, minus 4 times negative 3, that becomes a positive 12. 9 plus 12 is 21. So it checks out. All right, number 10. Number 10, we're going to look at those two equations again. And I notice that my x's are opposites already in sign. One is positive, one is negative, but they're not opposite numbers. So if I multiply that top equation by 2, I get 4x plus 10y equals 14. And then my second equation, negative 4x minus 10y equals 2. Well, when I add those two equations, I get 0 equals 16. Well, when will 0 equal 16? 0 will never equal 16. So my answer is no solution. And the last one, let's go up here. The last one, this should be 15x plus 5y equals 5. Now you had to read the instructions though, because this was a little different. But you know you have that H after your Algebra 1, which stands for honors. So you had to have a little thinking here. It says express each equation in slope-intercept form. Everyone should know that's y equals mx plus b. So that just means solve each equation for y. Then determine without solving the system whether the system of equations has exactly one solution, no solution, or an infinite number of solutions. Okay? So if we solve this first equation for y, we're going to subtract 15x from both sides. And we're going to get 5y equals negative 15x plus 5. We're then going to divide through by 5 and get y equals negative 3x plus 1. Now we're going to do the same thing over here. So we're going to add 6x to both sides. And we get negative 2y equals 6x minus 2. Now divide everything by negative 2. Y equals negative 3x plus 1. Well, now you need to compare the two lines. Those two lines are exactly the same. So again, you say to yourself, what am I trying to do? I'm trying to find where they intersect. Well, if these two lines are exactly the same, that means they're going to be the same line, meaning they lie right on top of each other. So where do they intersect? Everywhere. So what's our answer? All real numbers. If they had the same slope, which was negative 3, and they had different y-intercepts, then we would know that the two lines are parallel. Parallel lines never intersect. Therefore, that answer would have been no solution. if when you solve for y, the slopes were different, then you know the two lines are going to intersect at one point. So those are the three scenarios you would have had. Different slopes, one solution. Same slope, same intercept, all real numbers. Same slope, different y-intercepts, parallel lines, no solution. I hope this helped. I hope you can see now where you made your mistakes. If you have any questions, you know you can email me with them.